Hello and welcome to the lecture on compiling with GCC. GCC stands for the GNU Compiler Collection. A compiler is a program that takes your programming instructions, in our case a C program, and converts it into machine code or some type of variation of this process. In order to ensure that our development environment is set up properly, so our Debian virtual machine, we want to go ahead and run these sudo commands that will upgrade our environment, and then also install some tools, one of which is the GCC, if not already installed on your machine, and some other packages. The build essentials comes with a few other tools that we may need to use. So the general compilation process of a C program is as follows. You create a file that is some text file. In this case, we'll say main.c. We feed it to GCC or some type of compiler. A preprocessor is ran, which we learned about in our Hello World example briefly. And then the compiler takes this code, this text, and then produces an assembly code from the C file. The assembly code produced by the assembler is some type of binary. It will eventually become binary. It will be converted from assembly code to actual binary instructions. The next process is called linking, and that's when we're basically patching in external code that we may need to use that we did not define. An example of this would be the standard library printf function. And at the end of this, an executable is finally produced. Now, this is a very high-level overview of what this process does. There's obviously a lot more to it, but now you have a general concept of how a compilation process works. So how do we compile our Hello World program? We kind of glossed over those details a little bit when we went over our Hello World example. So in order to compile our programming using GCC, we can simply just execute the statement below showing here, which is GCC, and then we pass in our C file. This will produce a binary named A, and typically with the extension .out. And you'll notice that after this command on this screenshot, I list out the content, and then you can see that there's an a.out file. And when I run that file, we'll say hello world. Again, these are some details that we kind of glossed over in our Hello World program, but this is just to give you an idea of our compilation process. So I want you to go ahead and give it a try now. Using either the Hello World program or some other type of program that you've written so far, just compile it. And for extra credit, look through the help section to figure out how to rename your executable. And you can do this by typing gcc-help. So after you've given that a shot, you can go ahead and unpause the video, and let's go ahead and switch over to Visual Studio Code and our Debian environment to just mess around and compile some programs. All right, let's go ahead and launch our Debian instance by hitting the Windows key and typing Debian. And we can also go ahead and launch code by typing in code, since we've set that up. Now, alternatively, we're going to go ahead and close this because this is automatically going to start a connection, and we can go ahead and do this a different way, I believe. We can go ahead and click on our icon or launch it from the Windows menu, so Visual Studio Code. And down here on the left, it will ask me for a remote connection. So we're going to go ahead and just do a new window. This will launch inside of here. I believe we can do, getting started or something along those lines, but we don't need this window anymore. We already have this open. So we're going to go ahead and want to open up a folder, and we can just make it this folder. This folder being our home directory. Now, this was an example from a prior lecture, so we're going to go ahead and delete all this code. And let's go ahead and just close out of our terminal real quick. Now, one of the first things that we should probably do is run some of those update commands. Let's go ahead and go to our terminal. We're going to click on New Terminal. And I already have a majority of these programs installed, but just so you can see me do it, it's a pretty good habit to get into. sudo apt update y. I'm going to ask you for your password. It will update. It says all packages are up to date. Clear the screen. So you have the list. You can go through and install stuff. The programs that we'll be using during this lecture is going to be GCC. Another one will be the development man pages. I believe that's also listed in the slides. So go ahead and install those because they will come in kind of handy. Okay, so let's go ahead and write our hello world example once again. We'll type in our include statement and our main function declaration. Now, actually, before we write anything else, let's just try to compile this program. So, like we said before, all we need to do is type GCC and then the name of our file. But our file is actually located inside of the C-dev folder. So let's see where we are. We're not in that folder. Our current working directory is home and Kane, or our username. So we're going to go ahead and change directories to our C-dev. We're going to clear the screen by typing clear, or I prefer to hit Control L. From here, we can ls list the files. We have an a.out. Let's go ahead and remove that, and let's not do it using the GUI. Let's use it the command line. And you remember how to look up commands? Well, I'll go ahead and tell you this command. It's already rm, but let's look at the man page real quick. So rm removes a file or directories, files or directories. So we want to remove a file. Well, it says that you can feed it options. This is how to use it, kind of. Here's the files. Here's all the different flags that you can set on them. It also says you can see these other documentation to figure out how to use those tools. I'm going to go ahead and quit out of that man page, and let's go ahead and remove our a.out file and clear the screen. And you can see it's gone from this folder in our GUI here. All right, so GCC main.c, enter. Now you'll see an a.out was produced on our left, and let's go ahead and ls to make sure. So let's execute that program, and nothing happens. So it actually compiled. Now let's throw some compiler errors to see what occurs. Let's see. So if I remove this semicolon, let us see what happens. Clear the screen, GCC main.c, and there we go. Expected a semicolon before the close bracket token. So it tells us where the error is happening, line 6. We look at line 6, the actual error in our code is from line 5. So let's go ahead and do that. Save. And now let's figure out another error that we can do. Maybe we can return, let us figure out what else we can do. Let's rename this function to something else. Let's like something else. Save that file, and now let's try to compile. And you can see it says undefined reference to main. So we can't actually find it. Do you remember how I said that our main function is where our entry point of our program is? That's how the operating system knows where to begin. So this function, we need to at least have a main somewhere or some variation of it. Now, in later sections of the course, we'll see that we can actually we can tell the operating system where our entry point of our program is. So it doesn't necessarily need to be named main. We can change it, and we can, as long as it exists inside of our code, it will begin there. So here we are. Let's try to, let's go ahead and write a printf here. And let's say hello world again, /n for a new line. Don't forget our semicolon at the end. Save that. Come back to our command line. Let's clear the screen. And just like we were doing before, GCC main.c. And you can see a new a.out file was produced. We can execute that, and it will say hello world. Great. So we've kind of learned a bit about how to compile our programs. Now, GCC has a large help section, so we could type gcc-help, and it will give us a bunch of different options. It also lists how where else we can go to read some additional information. So there's a lot of different options here, and then you can use different things like some type of V with a help to see some type of sub processes of these particular items. But for the most part, we don't really need to go through this necessarily. Now, the challenge I believe I gave you was to compile a program and make it have a specific name. So if we look through this briefly, we can see, and I already know this, that this dash lowercase o, it places it into an output file name. So let's try that. We're going to go ahead and get out of the main page, clear our screen. Let's go ahead and remove our a.out file and clear the screen again. Let's do gcc main.c, pass in the dash lowercase o flag, and let's call our program hello. Now, if we ls, and you can see over here, we have a program that's named hello. So we can go ahead and execute that program, and it says hello world. So you can see that there's a ton of different options inside of GCC. GCC is not the only C compiler. There's several different C compilers, but that is the main one that we're going to be learning and using in this course. So I think that's about it for our compilation process and our basic understanding of what's going on. We'll be digging into different compiler information later on in the course. So don't be too worried if it still seems like a black box to you. Some of these things will be explained in later lectures.